Okay, so the simple sort of maybe called formula or relation that we have for selection of k objects out of n objects, when we are choosing k objects out of n objects, we simply write it as n factorial divided by k factorial times n minus k whole factorial. We don't know where this formula or this relation came from. And similarly for n permutation k, we write the relation that n permutation k is n factorial divided by n minus k whole factorial. Now what's the intuition behind this, or what's the logic behind writing this thing in the way or what's the formal proof of the thing, that would really help us to digest the thing or understand it in the way, or give us more sense that why do we write it in this way. For that I would simply share the idea or the way that I learned from Dr. Javed, thanks to him, where he told it in the storytelling way. I would simply share that with you. Say for example, if I'm trying to arrange n things in that itself, like I'm looking for all the possible arrangements, all the possible shufflings of n things all together. It means if, say for example, I am arranging some 100 people on 100 chairs maybe. So when I'm writing n factorial or 100 factorial, it means I'm arranging all the 100 people on all available 100 chairs. So whatever the possibilities in this way which we did, so whatever the possibilities are there are these n factorial or 100 factorial possibilities. But the similar thing, the similar activity can be done if I choose, say for example, some k people first out of those n people. Like out of those 100 people which I am going to arrange on the 100 seats, if I am choosing some k people, some 10 to some 20 people out of those 100 people, like those 10 people are special ones. Say for example, if I have 100 students and I am arranging them on 100 seats, I am first choosing some 10 students, maybe they are the youngest students out of those 100 students, so I am choosing some 10 students first out of the 100. Then arranging those 10 students first on the front 10 seats so that they can see all the things happening in front of them easily. So what I did, I was meant to arrange 100 students on 100 available seats, and the thing that I did is I first selected 10 students who were the youngest out of those 100 students and arranged those 10 students on the front seats that were on the front of all the rows. I'm left with 90 other students who are a bit older than the youngest ones, those I have selected. So the next target is to arrange those 90 students on the available 90 seats. Now this thing makes a bit more sense, that I was meant to arrange 100 students on 100 seats. I first selected some 10 students out of those 100 students, arranged those 10 students on the front 10 seats, and then arranged the remaining 90 students on the remaining 90 seats. If I derive the relation for n choose k from here, I would simply divide both the sides by this term, which would give me n factorial divided by k factorial times n minus k whole factorial, which is the same relation as we specified earlier. That if I want to choose k people out of n people, I want to choose k things out of n things, this could be the possible number of selections that I can make. Similarly, as we earlier discussed, that when we choose k things out of n things and then arrange them all. This becomes the permutation of k things out of n things. So I can write the same thing like n factorial equals to n choose k times k factorial and n minus k factorial. I can replace this thing by the permutation of n taking k at a time. So I would say that this is permutation of k things out of n, because I selected k things out of total n things and then did all the possible shufflings of those k things. We earlierly discussed that this thing makes the permutation of k things out of n multiplied by the remaining n minus k whole shufflings would give me this n factorial. So if I derive the relation for permutation of k things out of n, this would become the same as we wrote earlier. So this is the simple technique of counting the possibilities for combinations of the things, for permutations of the things, or for the multiple step experiments. We would further talk on the remaining things and assigning the probabilities to the outcomes that are coming out of the experiments in the next part.